Hey, howdy y'all. Welcome back to the show. This is David with Country Boy Computers. Now we've done a lot of different testing over the last 2 months on different hardware. We've tried different GPUs, we've tried different motherboards. Yesterday we tested 2 different applications running our large language models. We pitted LLAMA against LLAMA.CPP that was built with CMake for our custom setup with the graphics 906 GPUs. But there's one thing that I have not done yet that I'm going to do today. I'm going to run LLAMA.CPP with GPT-OSS 20B on CPU and system RAM only. I've got 4 CPUs lined up for testing. Let's get into it. So we're going to be testing 4 different CPUs with LLAMA.CPP today. And I want to see if there's a direct correlation between Passmark synthetic benchmark results and what we see in tokens per second running these benchmarks today, so that moving forward we can determine the outcome of what a system will be just by looking at which CPU it is. If you're not familiar with Passmark, it's a synthetic benchmark website where you download a small package, install it, and it will run some benchmarks on your local PC and label what specs you have and then submit them back to their server, and then score your rig on a component by component basis for everyone to see. So the 4 CPUs that we're testing today are the i9-13900KF, and you can see the Passmark multi-thread rating for that CPU is huge, 57737, and the single thread rating is also staggeringly high, 4586. And the second CPU that we'll be testing is the AMD 9700X. Its multi-core thread rating is 37137, and single thread rating actually a little bit higher than the i9. Yep. And then the Xeon, again, I was supposed to have received 2697 V4 and they messed up and I haven't gone back to fix it. But the multi-thread is only 13. I was thinking it was way higher than that. And then the single thread is 2189 or 2181. And then last on the list is the i7-5930K. It's got the weakest multi-thread rating at 10,369 and a single thread of 2,057. But what this does have is quad channel RAM instead of dual channel RAM, which is what the AMD and the Intel i9 have. Granted, the i7 is 10 years old. It's running on an X99 platform that's 10 years old. Its rating is 10,000. The 13900 is just almost 60,000 on a multi-thread rating. So what I want to do is do some benchmarks on LLAMA.CPP, and see how they relate to the numbers that we see on this. So moving forward, we know a pretty good idea. What we can look at on the screen is what we'll get at of our computer running LLM locally with the CPU. And here's what we're working with today. Check out that bad boy graphics card. Yeah. All right, let's get into our build bin, our documents, and we're gonna load GPT-OSS 20B on our i9-13900KF. We can see it is ready for go. 14 gigs in use, and we will start the server, or excuse me, start the benchmark. kept the context to a reasonable level here, 16,000, since we are running on a system RAM only. And on this system, I was gonna boot initially without the RAM overclock on, but I couldn't do that. The system didn't like it. This is EXPO RAM. I think it's made for, it's an AMD preferred RAM stick. And my Intel board didn't like it. It would not boot with that off. So I have to have it on. And you can see here I'm at 6,000 megahertz. And we're getting 29 tokens a second on CPU only. And I'll show you here just a minute. So when you launch LLAMA.CPP, it launches the server, launches a local port that you can pull up in a browser. So I will do that. You gotta hold control and click and it opens that. And I will copy and paste the actual question that my benchmark uses, which is explain the fundamental principles of quantum computing, including superposition and entanglement, and discuss the primary challenges in building a large-scale quantum computer. So, you know, easy stuff. Shouldn't take it that long. But this way you can actually see what it's like in interactive mode on CPU only. And of course it's going to computate its own tokens a second in the bottom. So I mean, it wasn't super fast, but once it gets to the response stage, time to the first token might take a little while, but it's completely usable. All right, you see here, it calculated 27.12 tokens a second with a sample size of 1,024 tokens, 37 seconds for the full response. That's on an i9-13900 on a Z690 MSI Carbon motherboard. All right, here's what we're going to be operating on for the AM5 test. I got this little doozy the other day on Newegg. It's a pretty cool little setup for a micro ITX board. It's got a little carrying case. I got the Wi-Fi antenna strapped to the top. I got a 3090 sitting in there. But the CPU we're going to test is the 9700X. And I'll just ask y'all this. So I just moved the RAM sticks over here. Is it me? Is it just me? Or does it take a really long time to train those RAM sticks current day? Man, I pucker up every single time. That light goes red, sits there and sits there and sits there. And then it finally turns white. Whew, sigh of relief. Anyway, getting booted here. All right, here we are booted up on the AM5 platform. I've got the same RAM in there that I had on the i9. I have EXPO enabled on this run, so it's at 6,000. I'm gonna run it a second time with that disabled, and we'll see how bad the performance takes a hit with a slower RAM. Also, I had to disable the internal graphics on the 9700X as it caused the model load to fail. As it tried to put 12 gigs on an internal iGPU. It doesn't work. All right, here we go. RAM's at 14.5 gigs. CPU's showing higher utilization than the i9 for sure. 52.97 tokens a second. Also, I took the same exact NVMe drive from the i9 test bench and put it in my daily driver as well. So I'm trying to keep everything the same as much as possible. Looks like 23 tokens is going to be the magic number for the 9700X with 6,000 megahertz RAM. I'm interested to see how bad that's going to take a hit. But after this finishes up here, I'll pop open the chat prompt. Okay, 23.37 tokens a second. And I'm going to enter my quantum computing question into the prompter. And let's just watch and see what a 9700X looks like when you try to interact with the model. There's a little delay, so was the other one. I guess, I mean, to me that looks pretty noticeable. My numbers, well, I mean 23 versus 30 is quite a difference, percentage-wise. We'll see what their calculation is here at the end. Okay, they show 19.44 tokens a second, 52-second response time. I think the i9 was 37, if my memory serves me correctly. But I'm gonna boot her down and put the RAM to standard or disable the overclock, and we'll try it again. So we've got the 9700X rebooted here with EXPO off. You can see our RAM speed is now 4800 instead of 6000. Gonna load up our model, which is GPT-OSS 20B. Get our llama bench ready to rock and roll. Let's see what happens. $19.11 tokens. So yeah, RAM speed definitely makes a difference. I mean, that's 10% roundabouts. And that was just going from 6,000 down to 48. I mean, if you had some 8,000 megahertz, some high end, I haven't even looked at RAM costs. It's so ridiculous, the cost now. I mean, I got a 64 gig kit several months ago, and I think it was $150. That same kit's like $600 now. It's ridiculous. It's very steady, 19 and some change all the way through it. But yeah, you can see there, CPU matters, RAM speed definitely matters. Next up is the X99. If my new board boots and recognizes all 4 memory sticks. I tell you, I won't even get into it. I did work with some voltages. Evidently there's some bulletin boards out there that state that in the X99 BIOS for that ASUS workstation board, you have to go in and configure the CPU system agent voltage and give it a positive offset of 10, 20 thousandths, I think. Okay, 19.5 tokens. And I tried and that didn't work. So let's do our prompt and see just how bad 19 tokens a second looks. Again, the exact same prompt. Well, maybe. All right, I had to do a little redo there. Firefox had kind of crashed on me, so. Let's try it again. It's looking better. I was at least able to copy paste some text in the prompt. When I tried it just a moment ago, that didn't even work, so. Really skewed the results, if you know what I'm saying. Okay, we're getting a little bit of a response here. It's not terrible. I should have timed that just to see how long the first text took to start showing. I mean, this might be useful depending on how patient you are. Alright, it's reading 16.42 tokens, 62-second response time. We read 19.5. I'm thinking like 20-ish tokens a second is about the very bottom on this model, GPT-OSS 20B, that you want to be running and maintain sanity. All right, here we've got our Gigabyte X99 UD4 for monster low profile, R7 graphics, quad channel RAM, and the puny little i7 in there. Some nice liquid cooling. All right. I can't tell you how exciting this is for me to have an X99 working with all 4 of my RAM sticks showing. So we're truly going to be able to test quad channel RAM speeds on CPU run LLAMA.CPP. So let's get our server going. And it's filling it up. All slots are idle. Llama bench. All right, here we go. We got a X99 Gigabyte UD4 motherboard and 4 sticks of 8 gig HyperX. It's running at 2133 right now. It does overclock XMP to 2666. So I'll run that test next. Now I also have a Xeon that I want to run next. I intended to order the 2697 V4 because it is a bomb diggity CPU. Not as good, of course, as the 2699, but just by a little bit on that multi-core. If you reference the Passmark sites that we talked about earlier. So 13.55 tokens a second on the Intel i7-5930K, which is a 40 PCIe lane CPU from 2014, 15, 16 maybe. I don't have that in front of me. And I don't have Wi-Fi on this yet. I haven't plugged in my little dongle. So I'm just running local here. You can see our GPU is doing nothing because it is the little R7. I think it's a 2040. Well, it's got 2 gigs of RAM, VRAM. CPU 56% utilization. 157 watts at the wall. I'll be quiet and fast forward some of this. All right, you can see it there, 13.57 tokens a second on the i7-5930K. And we'll load up our interactive prompt from the host here, LLAMA.CPP server, and we'll put in our question just like we've been doing. And I'll be quiet and be still because it's probably going to take it some time. You know, one thing that just occurred to me while I'm sitting here staring at this screen is that this LLAMA.CPP I built for the graphics 906 GPU, and on the GitHub site there's some codes, I haven't even looked at it, where you can build your LLAMA.CPP specifically for your CPU. I think. I'm pretty sure I saw that on there as an option. 12.25 tokens a second, 83-second response time. All right, I'm gonna shut this down, turn on XMP, I'll be right back. Okie dokie. So I booted with XMP profile 1 enabled, which is the 2666, and it crashed and wanted me to reload the default optimal settings. So I canceled that, went back into BIOS, and I uploaded or selected profile 2, which is a 2400 RAM profile. And we'll give this a shot and see what kind of difference we see. We're at 13 in the middle, 13 and a half, 13.3 at our base clock on the RAM. LLAMA Bench 2400 XMP RAM quad channel. Let's see what we do. Before the break, somebody had mentioned, I'll have to look it up, that I intended to run the two MI50s and the Radeon 7 on this board, and they said the MI50s wouldn't boot because the above 4G decoding is not an option in the BIOS. But I just looked, this is on BIOS F22, and it is in there. And there's actually 2 more BIOS updates after the one that I have. And one says it's for memory compatibility, which might fix our profile 1 issue. And then another is for CPU additions. And that was in 2018. The BIOS I'm running now, I think, was dated 2016. So we're looking here, 13.9, 13.9. That's nothing. I mean, we went from 2133 to 2400. but that's a minimal gain. I mean, half a token a second. I'll give it another shot here on profile 1, see if we can get 2666 to boot. I'll have to tweak some voltages, or not exactly sure what it'll take, but I'm gonna give it a try. And I'll update the BIOS too and see if that helps. All right, 13.91 with XMP profile 2 set up. Let's see what that looks like in an interactive fashion. All right, that answer seemed a little bit cut off, but it got to the 1024 tokens at 12.6 a second. It took 80 seconds, but it left our answer a little short. So anyhow, all right, I'm gonna get the new BIOS on here and try to get profile 1 set up for the RAM, and we'll give that a shot on the i7. And if that doesn't work, I'm gonna swap out the i7 and put the Xeon in here and see if that gives us any boost. We'll be right back. Super fantastic. It is so nice when stuff works out. I downloaded F24C, I think it said. Put it on a fat formatted USB drive. Booted into BIOS. You have to hit Alt for an extra prompt to come up, and that's where the QFlash option is. Got the new BIOS installed. Profile 1, XMP 2666. Took just like butter. All right. I just can't echo enough how frustrating it is. One, listening to my voice, I understand that. But two, when you have a piece of hardware that just ain't quite right, like my board was, the Asus X99E workstation board. I can't believe that I bent a pin on it. It worked on the first test with the i7, which is what it came with. I mean, I've worked with CPUs in and out, swapping them for years and years and years, and I've never broken one myself. And I assume I did that, just, I don't know. But man, if you don't have good CPU connection and there's even just one pin, I mean, this is the socket is 2011 V3, but it's named that because there's 2011 CPU pins on that socket. And if just one is off base by, I mean, like a half a millimeter, it screws up the whole system. But anyway, here we are, 14.7. So we gained a whole token this time from our base of 2133. It's pulling about 170, 175 at the wall. I don't think I said that much on those other two tests. With the AM5, it wasn't even plugged into the kilowatt machine, so sorry I don't have any figures for that spec on this video. All right, so with profile 1 enabled on our XMP memory, we get 14.14 tokens a second, running on an i7-5930K. Reboot her down, swap out the Xeon, we'll give it some more. So I guess this is going to be the last test that I'm going to do, because again, I got the Xeon in there, and this is the 2667 V4. It was sent to me in error. I'd ordered the 2697. But it doesn't like the RAM that I'm using, so it only shows half, 16 gigs. And I'm going to go ahead and press my luck and see if I can even get it to run. But it has no XMP profile, and we're not in quad channel. But according to the Passmark synthetic ratings, this is about a 60% improvement in pure CPU multi-core power. So let's get to it. It's loading. So far, so good. And I know Xeon probably prefers ECC RAM. I don't have any DDR4 ECC RAM laying around. I've got about a dozen or so DDR3 ECC RAM banks, and maybe I'll list those. They're registered though, so they're really picky. And you can see, goodness, we are right. I don't know how it's committed 18 gigs when I've only got 16 gigs available. But anyway, I guess they got a little swap action going on the NVMe drive. Yeah, 11.65. We're definitely hitting a bottleneck between maxing out our RAM. I guess it swaps it to the drive. But it definitely misses the quad channel RAM. That's disappointing. I was really hoping to see what the numbers would do when we swapped the CPUs out. I might tinker with the voltages and such to see if I can get all 4 channels activated. But man, I'm having nightmares thinking about it. I can't tell you. I know I've already said this about 4 times in this video. I must have rebooted that X99 1,000 times 2 weeks ago in the course of 3 days. Take the CPU out, check the pins, bend the pin, tighten the CPU up, loosen the CPU. I want to be done with that. The bright spot is it's only pulling 140 watts at the wall. I'm a glass half full kind of guy, right? All right, the Xeon pulled 11.65 tokens a second. And I'll be quiet through this because it's going to be slow. All right, that test finished at 10.61 tokens a second in 96 seconds. And we only got to 1.4 when usually it gets down into the 2s and the 3s. But I actually sat and read some of that this time since it was going so slowly. Oh man. I'm a country boy computer kind of guy, not a quantum computer kind of guy. Anywho, I think that's just about going to wrap this part up. We appreciate you.